Hello students, Miss Slyman here, and I'm going to talk to you today about mathematical induction. So the proofs that we've seen so far have been mostly algebraic proofs, and this combines algebraic proof along with the idea that if I can prove something that's sequential, or if I have something that's sequential, I can prove it to be true using this idea of induction. And so I can think of it in terms of dominoes falling. So if I have a stack of dominoes, if the first domino falls, then we can assume that each subsequent domino is going to fall as well. So the way that an induction proof starts is that, or the idea with induction is that for each statement to be true, the expression before it has to be true. So here are the steps of an induction proof. So step one, you want to identify the mathematical statement that you're trying to prove to be true. So we want to write it as a P sub n statement. And normally it's going to have a left-hand side and a right-hand side. We want to show that the initial statement is true. So that's typically n equals 1, but it depends on how this statement is set up. Because if it's set up that P sub n is true for n greater than or equal to 3, then we would start with n equals 3 as the first term. The next thing we're going to do is we're going to assume that the general statement is true. So you actually need to write on your paper, assume P sub k, that's supposed to be a P, is true. And you actually want to write down what that's going to be with a left-hand side and a right-hand side. The next thing we need to do is we need to prove that the k plus 1 statement is true. And typically we're going to do this with algebra, working with just one side. Always, we're going to use the P sub k statement, which we've assumed to be true. So if the first statement was true, and we've assumed that some next statement is true. So if the first one was true, we've assumed some middle one is true and then proven that the next one after that is true. Well, if the first one was true and the next one is always true, that means every statement must have been true. So we're going to end by stating our conclusion. And typically this involves writing a sentence. And we write out this sentence. Given that P sub 1, P sub 3, whatever, was true, and we have proven that k plus 1 is true, then we know by induction that all of the expressions are true, and generally we write, then we know by induction that P sub n must be true. So let's look at this in action. All right, here we have an arithmetic sequence, and we're saying that its end result is going to be n over 2 times n plus 1. Well, if I think about this, this is what we've already told you is true. I've got first term plus last term times n over 2. So my arithmetic series is that my sum of n terms is going to be n over 2 times first term plus last term. Yeah, so that's what we've said. Well, let's go with induction. So my P sub n statement is that 1 plus 2 plus 3 plus n is equal to n times n plus 1 over 2. So this is my statement that I want to prove to be true. This statement starts for n values greater than or equal to 1. So my P sub 1 statement is that on the left side, we're just going with one term. It's equal to, on the right-hand side, we'd have 1 times 1 plus 1, divide by 2. Well, that's 2, so 2 over 2 cancels, so that checks out. If I want to verify it for myself, I could even keep going. P sub 2 is going to be 1 plus 2, and then I would have 2 times 2 plus 1 over 2. Again, that's going to cancel. I've got 3 left. 3 equals 3. That's true. So now I'm going to say assume P sub k is true. So that is 1 plus 2 plus 3, ending with k, is equal to k times k plus 1 over 2. So if n equals k plus 1, then we would have 1 plus 2 plus 3 plus k plus 1. We want this to be true. We want this to equal k plus 1 times k plus 1, so that's going to be k plus 2 over 2. Well, I'm working just with my left-hand side, so my left-hand side, if n is k plus 1, I have 1 plus 2 plus 3 going down all the way to k plus 1. This is my P sub k statement. So that's up here, so I can replace it with k times k plus 1 over 2 plus, here's my k plus 1 term. I want to add these two up, so I need a common denominator. Divide by 2, multiply by 2 on top to make the common denominator. So now I end up with, that's going to be, on this left term, I have k squared plus k. Over here, I have 2k plus 2k plus 2 all over 2. That is going to be equal to k squared plus 3k plus 2, which is k plus 1 times k plus 2 over 2, which is what we wanted. So that's now the right-hand side of the P sub k plus 1 statement. Therefore, P sub k plus 1 is true. P sub 1 was true by mathematical induction. P sub k is true for all k greater than or equal to 1.